Okay children, let us continue with the chemical properties of alcohol. Now we are going to study about the third type of chemical property. In a way, they are the special reactions of alcohol. In this case, the first reaction, let us consider dehydration. When alcohols undergoes dehydration, at about 443 Kelvin, you will be getting alkene as the product. Here the temperature is very important, otherwise the nature of the product will be changing. So we can consider alcohol, that is, we are talking about ethanol, when undergoes dehydration in presence of acid at about 443 Kelvin and produces ethene as the product. Let us study children how the process will go on, that is the mechanism of this reaction. This is the second mechanism we are studying in this chapter. Let us consider the mechanism. In the first step, protonation of alcohol takes place, that is CH3, CH2. The first step is protonation. Protonation means addition of H+, that is CH3, CH2OH plus H+ will give you CH3, CH2, OH2 plus. Is it clear? You are getting an addition product which will be losing a molecule of water. That is, in the second step we can say that removal of OH2 will go on, H2O, removal of water, so that from this addition product CH3, CH2, OH2 plus, it loses one molecule of water and results in the formation of a carbocation. You are getting a carbocation. Third step we can consider deprotonation. Deprotonation means again removal of H+, that is this carbocation will be losing one H+ and it results in the formation of CH2 double bond CH2. Is it clear children? Mechanism is very simple. It takes place in three steps. In the first step, protonation of alcohol. Second step, formation of carbocation. And third step, deprotonation. And finally, you will be getting the product. Is it clear? Now, let us consider the second reaction, that is oxidation. All the three types, that is primary, secondary and tertiary alcohol, will give you different products in oxidation. Let us consider one by one. If you just consider primary alcohol, that is, let us consider CH3, CH2OH, undergoes oxidation. It can be in presence of strong oxidizing agents like alkaline KMnO4 or acidified K2Cr2O7, that is, alcohol undergoes oxidation. And in the first step, you will get aldehyde, which further oxidizes, undergoes oxidation and produces carboxylic acid as the product. Is it clear children? Alcohol on oxidation will give you aldehyde. That on further oxidation will give you carboxylic acid. Please note one point. In both these cases, both the aldehyde and acid will have same number of carbon atom as that of alcohol. Now let us consider if it is secondary alcohol, that is CH3, CHOH, CH3, propane to old, undergoes oxidation under the same condition. In the first step, you will get a ketone. That is CH3COCH3, which has same number of carbon atom as that of alcohol, which on further oxidation you will get a carboxylic acid which is having one carbon less than that of ketone. Is it clear? That is, first secondary alcohol on oxidation will give you a ketone in which the number of carbon atoms are the same, but this ketone on oxidation will give you an acid which is having one carbon less. Is it clear? Now third one you can consider, suppose if it is tertiary alcohol, that is 2-methyl propane 2-ol. Tertiary alcohol on oxidation, again you will be getting a ketone which is having one carbon less compared to that of alcohol. Here you see in case of alcohol you are having 4 carbon atoms, but in the case of ketone only 3 carbon atoms are present. So here you are getting a ketone which is having 1 carbon less, and that on oxidation will give you acid which again reduces the number of carbon atoms. That is, in the ketone 1 carbon is less, and from ketone to acid again 1 carbon is less. Is it clear children? So all the three varieties, that is primary, secondary and tertiary alcohol, undergoes oxidation and will give you this products. Okay. Now let us consider the third type of reaction in this, that is dehydrogenation. Dehydrogenation. Here dehydrogenation takes place in presence of copper as the catalyst at about 573 Kelvin. That is, if you consider primary alcohol, undergoes dehydrogenation in presence of copper as the catalyst at about 573 Kelvin and produces aldehyde. Is it clear? Primary alcohol undergoes dehydrogenation and produces aldehyde. Suppose if it is secondary alcohol, CS3, CHOH, CS3 undergoes dehydrogenation under the same condition and will give you ketone as the product. CS3, CO, CS3 will be the product. Suppose if it is tertiary alcohol, that is CS3, COH, CH3, CH3 undergoes dehydrogenation under the same condition, and here we can say that instead of dehydrogenation in case of tertiary alcohol, actually dehydration takes place, or you will be getting CH3, C double bond CH2, single bond CH3 as the product. Alkene will be the product. Is it clear, children? Primary alcohol will give you aldehyde, secondary alcohol will give you ketone, but tertiary will be giving you alkene as the product. Is it clear? That is about the general chemical properties of alcohols. Now first let us study about the commercially important compounds in this alcohol series. That is, we are just going to study only about the first two compounds, that is methanol and ethanol. That also in short. If you consider this methanol is otherwise termed as wood spirit. Methanol is otherwise termed as wood spirit since it is produced by the destructive distillation of wood. Methanol is formed by the destructive distillation of wood, so it is also termed as wood spirit. It is prepared by the catalytic hydrogenation of carbon monoxide. Carbon monoxide undergoes catalytic hydrogenation, that is in presence of zinc oxide or chromium oxide as the catalyst at about 200 to 300 atmospheric pressure and 573 to 673 Kelvin and results in the formation of methanol. Is it clear, children? It is formed by the catalytic hydrogenation of carbon monoxide at high temperature and pressure. This methanol is completely soluble in water and it is highly poisonous in nature. Small traces of intake of small traces of methanol can cause us blind, and if you are taking in large quantity, it can cause even death. This methanol is generally useful as a solvent for paints, varnishes, and even for the manufacture of formaldehyde we are using methanol. Is it clear, children? Next one, you consider ethanol. You know, ethanol is generally produced by fermentation of carbohydrates. If you just consider sugar, that is C12H22O11, undergoes hydrolysis in presence of invertase, that is the enzyme which is present in yeast, and produces glucose plus fructose. That is, when you are studying biomolecules, you are seeing that glucose and fructose are showing difference only in their structural formula, molecular formula, they are one and the same. So this compound undergoes further decomposition in presence of cymase and produces ethanol and carbon dioxide. Okay, so generally it is produced by the fermentation, or it undergoes anaerobic respiration. That means we can say that in the absence of oxygen, the fermentation takes place and results in the formation of ethanol. You can prepare ethanol even from grapes. That is, as grape ripen, it becomes the amount of glucose in it increases and the skin of this grapes contains some yeast. So when you crush this grapes, this yeast comes in contact with this glucose and fermentation occurs, and that results in the formation of ethanol. Is it clear, children? Ethanol is generally used as a solvent. It is used for the manufacture of paints, lacquers, varnishes, etc. It is even used in cough syrup. And this ethanol has the property of directly affecting the central nervous system. Is it clear, children? In order to make ethanol unfit for drinking, we generally add copper sulfate to give it a color and pyridine to give it a foul smell. Is it clear? This process is termed as denaturation. To make it unfit for drinking purpose, we add copper sulfate and pyridine. Is it clear? That is about the preparation or the properties of this commercially important compounds. Now let us see how to differentiate or how to chemically identify alcohol. That, children, will study in next.
next class.
Thank you.